Hi, welcome to Unit 4, Day 9. This is part 2 of Unit 4 review, and this is the play posit. All right, so the project that you're doing is the Meet My Molecule Unit 4 final project, and one of the purposes of this project is for you to use your knowledge from this unit to predict properties. Now, in order for us to be able to use our knowledge that we've gained during this unit, it's a good idea to review what we've learned prior to spring break. And this play posit, by the way, if you're doing this as a play posit, it will be graded. So this will help us, what we're going to cover here will sort of help us with the green section of our project. Okay. So what are we going to review? We're going to review how to tell if a substance is a metal, ionic, or covalent. We're going to review how to predict the properties of a substance, describe its Lewis dot structures, and how to recognize if something is an acid. That's what we covered so far. And the way we review it, there will be 11 questions here. Not all of them will count as a grade. Some of them will be just for you to pause. The first question for each of the 4 topics above will be a primer. None of those will count, just to sort of prime you and see what it is that you remember. Then we'll briefly review the topics with a couple of quick slides, and then there'll be at least one more question that's similar to the first primer question, and at least one of those will count. So the first thing we're going to review is how to tell if a substance is a metal, ionic, or covalent. And this was covered in Unit 4, Week 1. This is in the Tuesday and Thursday folder, so Unit 4, Day 2, and Unit 4, Day 4. So if you want to, you can always go back to those folders. All right, so here's our first CFU, and this is our primer, so it doesn't count, but give it a go. Which of the following is an ionic compound? You can pause the video if you need to, and then when you press play again, the answer will be revealed. Great, the answer is C. The reason why it's C is because lithium, which is here, it's a metal, and fluorine is a nonmetal, and ionic compounds are made up of metals and nonmetals. So let's just review for all the 3 substances. For metallic compounds, this was in your notes, metallic compounds, they have metal atoms only. Ionic compounds are made up of metals and nonmetals, and covalent molecules are made up of nonmetals only. And we can figure out what type of atoms we have with metal or nonmetal from the periodic table. Okay. So now that you've seen that, this next CFU does count. So which of the following is a covalent molecule? You're going to select all that apply. So you might need to pause the video just to check the answers and take your time with this. When you press play again, or after you've done the question, then the answer will be revealed. Okay, so the answer is choice B and D, and covalent molecules are made up of nonmetal atoms only, and that would correspond to choice B and D. All right, now we're going to talk about how we predict the properties of different substances, and those were also covered in Unit 4, Week 1, Tuesday, and Thursday folders. So again, if you need to, you can review back there. So here's our primer CFU. This one does not count, but you want to think about it. So which of the following are properties of MgNO3, which is also known as magnesium nitrate? So you can pause the video now, and when you press play again, the answer will be revealed. Okay, so magnesium nitrate is an ionic compound. I know that because magnesium here is a metal, and nitrogen and oxygen are nonmetals. So if it's made up of metal and nonmetals, it's ionic. So ionic compounds are dull. As a solid, they are insulators, meaning they do not conduct electricity in their solid state. So if you were to take a conductivity probe and put it in a lump of salt, it will not conduct. However, in aqueous solution, they do conduct. So if you dissolve that salt in water and then use a conductivity meter, it will be lit. Many ionic compounds are soluble, so it's most likely soluble, and they have a high melting point. So all ionic compounds have high melting points. So these are the properties that you should have predicted. Okay, so what we're going to do is just, we're not going to go over the properties of each thing because you can just pause the video and read it. But here are the properties of metal. So if you need to, you can pause and read what they are. By the way, malleable is referring to the fact that you can bend a metal and it doesn't break. The opposite of malleable will be brittle. Okay, now let's move on to the properties of ionic compounds. So again, you can just pause and read. There's one thing I want to highlight here. Good. Remember, ionic compounds are insulators as solids, but they're good conductors in molten, which means liquid when you melt them as a liquid, or in aqueous form when you dissolve it in water. So if you just take a solid piece of salt, it will not conduct. It's an insulator. But if you dissolve it in water or melt it into a liquid, it will be a good conductor. Okay, so let's move on to the properties of covalent molecules. So these are the properties, again, you can pause and read. The only thing I want to point out is covalent molecules are insulators, except for if it's an aqueous acid, an acid dissolved in water, then it will conduct. So aqueous acids are conductors. And then many polar molecules are soluble and nonpolar molecules are insoluble in water. And when I say soluble, it means it does not dissolve. Insoluble means it does not dissolve. So nonpolar covalent molecules do not dissolve in water and polar molecules do. Okay, so just a quick reminder for covalent molecules, if you're thinking about the solubility, you're trying to predict the solubility, you'd first need to know if it's polar or nonpolar, which we're going to learn about later on this week. So that will be cool how to recognize that. But anyway, so if it's polar, it'll be soluble, it'll dissolve. And if it's nonpolar, it'll be insoluble and it would not dissolve in water. If you're thinking about conductivity for a covalent molecule, you need to know if it's an acid or not. So if it's an acid, it will be a good conductor in aqueous solution. So when it's dissolved in water, it will be lit, it will conduct. And if it's neutral, it will be an insulator in aqueous solution, so it will not be lit. Okay, so this CFU4 will count. So you're going to figure out what's the properties of C2H4O, which is a polar and neutral molecule. So pause the video now. When you press play again, the answer will be revealed. Okay, so it's a covalent molecule because all of them are nonmetals, then tells me it's polar and neutral. So all covalent molecules are dull. They're all insulators as solids, but in aqueous solution, it will conduct if it's an acid. Since this is neutral, it's not an acid, then it's going to be an insulator. It's soluble because they said it's polar, so that means it's going to dissolve. And covalent molecules either will have a low or medium melting point. So we've selected low melting point here. Okay, so we looked at how to determine something as a metal, ionic, or covalent, and how to predict their properties based on that. So now we're going to go into describing Lewis dot structures. This was covered in Unit 4, Week 2, Tuesday's folder. All right, this is a primer question, so it doesn't count, but give it a go. What is the chemical formula for diethyl ether? Pause the video now, and you press play again, the answer will be revealed. Great, so we would just count up the number of carbons, hydrogens, and oxygens in this structure, and the answer would be B. All right, another primer question. Describe the circle bond in words. So that bond here that's circled in blue, how would you describe that in words? Pause the video now. When you press play again, the answer will be revealed. You can call it nitrogen-carbon double bond or carbon-nitrogen double bond. So let's talk about how we describe bonds in words. First of all, there are different types of bond orders, meaning bonds which connect atoms can either be single, double, or triple. So here's our single bond, here's our double bond, here's our triple bond, right? Notice that single bond has one line or one bond connecting them, double has two, and then triple, of course, would have three. So when we're describing bonds, what we do is we would name the two atoms in the bond and then name the order of the bond if it's single, double, or triple. So in this example, we have nitrogen and carbon connected by a single bond, so we would call it a nitrogen-carbon single bond, or you can call it carbon-nitrogen single bond. The order of the atoms do not matter. Here we have another example, it's carbon-carbon double bond. Here we have another example, oxygen-carbon double bond or carbon-oxygen double bond. All right, so this CFU does count. How many carbon-oxygen single bonds does caffeine have? So carbon-oxygen single bonds. Pause the video now and you press play again, the answer will be revealed. Great, the answer is 0. These are not single bonds. These are double bonds, so the answer to that would be 0. Okay, this next CFU, this one will not count, but you want to give it a go anyway. Oops, describe the circle bond in words. So it's a carbon-hydrogen single bond or hydrogen-carbon single bond. Remember, the order of the atoms do not matter. Okay, last final note. The abbreviated structures, you may see this when you're searching up structural formulas for your project, so we'll just quickly go over this. When you have an abbreviated structure like this, where there's a lot of atoms seem to be missing, each corner and end line is a carbon atom with enough hydrogens attached to it to give that carbon a total of 4 bonds. So these corners here and these ends are all carbons, and there are hydrogens attached to each of those carbons to give the carbon a total of 4 bonds. You don't need to know how to do it, you just need to know how to recognize it. You just need to know that when you see something like this, that there are carbons here, and there are carbons here, and there are carbons here and here, with hydrogens possibly attached to them. Okay, the next thing that we're going to go over is how to recognize if something is an acid, and this was covered in Unit 4, Week 2, on the Wednesday folder. So the reason why this is important is because remember that covalent molecules, their conductivity depends on if it's an acid or not. If it's an acid, they are conductors in aqueous solution. Other than that, they will be an insulator as a solid, as aqueous. If it's not, it will be an insulator. All right, so which of these molecules is or are acids? Remember, this is a primer question, so it doesn't count. You can select all that apply. Pause the video now. When you press play again, the answer will be revealed. Okay, the answer is choice A and C, and we're going to talk about why that is. So how do you recognize an acid from its chemical formula? You have to remember the expression H in the front, COOH in the back. So when you see an H in the front of the chemical formula or a COOH in the back, then you know it's an acid. The exception of that will be water, which has an H in the front, but water is neutral, it's not an acid. And when we say COOH, it could also be written as CO2H. It's called a carboxylic acid, and this is what it looks like. You see it has a carbon-oxygen double bond and a carbon-oxygen single bond, and a hydrogen attached to that oxygen. So let's look at some quick examples. Here we have H's in the front. These are examples of acids with H's in the front. And here we have an example of an acid with a COOH group in the back, vinegar. All right, so you're going to try this CFU. You're going to circle all of the acids. This CFU doesn't count, but do your best. And when you press play again, the answer will be revealed. Okay, so here are all the acids. And the one that you want to watch out for, of course, is water. Remember, even though there's an H in the front, water is neutral. B and J both have H's in the front, so they're acids. And then D and L have a COOH in the back, so they're acids. The rest of them are not acids. All right, this is the last CFU, last thing we're going to talk about. So this one actually does count. Which of these covalent molecules will conduct in aqueous solutions? Select all that apply. So hint, hint, acids conduct in aqueous solutions. So that's what you're looking for. All right, so pause the video now. When you press play again, the answer will be revealed. All right, so choice C and D are acids because they have an H in the front and a COOH group in the back. All right, that is it for this video. Hope you had a good time reviewing. Have a quality day.